Hello students, now we are going to see an example of a vector field which is not conservative. So show that this thing x sin y plus y square x sin y vector I plus y square cos l vector j is not conservative. So this is your m, this is your n, this is a vector field in R2. So conservative if and only if dou m by dou y equal to dou n by dou x. So what is dou m by dou y? It is x cos y and what is dou n by dou x? Oh sorry, this is not z, it is actually x. What I mean is x. Then only this becomes a vector field in R2. So what is dou n by dou x? It is minus y square sin x. They are not equal. X cos y not equal to minus y square sin x. So this is not conservative. Therefore vector f, which f this way, is not conservative. Okay, so what you understand from this example is conservativeness of a vector field depends upon a perfect balance, some kind of balance between its components. So once that balance is lost, you will have a non-conservative field. നിങ്ങൾ എന്താണ് വെയിങ് ബാലൻസിൽ എന്തെങ്കിലും അരി തൂക്കിയെടുക്കുന്നത് പോലെ അല്ലെങ്കിൽ പഞ്ചസാര തൂക്കിയെടുക്കുന്നത് പോലെ. സോ ദാറ്റ് ഈസ് എ പെർഫെക്റ്റ് ബാലൻസ് ബിറ്റ്വീൻ ഇറ്റ്സ് കമ്പോണൻസ്. അപ്പോൾ മിക്കവാറും നമ്മൾ തൂക്കുമ്പോൾ 2 കിലോ അരി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒരിക്കലും അത് പെർഫെക്റ്റ്ലി 2 കിലോ ആവില്ല, ചെറിയ വ്യത്യാസങ്ങളുണ്ടാവും. ആദ്യം നമ്മൾ എടുക്കുമ്പോൾ ചിലപ്പോൾ 1/2 കിലോനും ഒക്കെ വ്യത്യാസം ഉണ്ടാവും, ചിലപ്പോൾ 1.5 കിലോ ഉണ്ടാവുള്ളൂ, ചിലപ്പോൾ 2.5 കിലോ ഉണ്ടാവും. സോ most the lesson you have to learn from this example is most of the vector fields are not conservative. Most of the vector fields are not conservative. If there is a perfect balance between its components like this, then only the vector field is conservative. Okay, now we will do definition. Differential form. Differential form means it's an expression of the form m dx plus n dy plus p dz. So this is in R3 and it is m dx plus n dy if it is in R2. This is just an expression where here m, n and p, they are functions of x, y and z, and in this case, in the second case, it is m and n are functions of x and y. So observe that there is a one-to-one correspondence between vector fields and differential forms. Vector fields and differential forms, there is a one-to-one correspondence. How? If I have a vector field, vector f equal to I don't want to write f, so I will just only write mi plus nj plus pk if I have a vector field mi plus nj plus pk, what is the corresponding differential form? Can you tell me? Here m, n and p, they are functions of x, y and z. So corresponding differential form is, what is the natural thing? M dx plus n dy plus p dz. Conversely, if you have a differential form m dx plus n dy plus p dz, then the corresponding vector field is mi plus nj plus pk. Okay, and a differential, so we will make another definition. A differential form is exact let me call that differential form as m dx plus n dy plus p dz is said to be exact if there exists a function small f such that, of course, smooth function, small f such that what happens? This m dx plus n dy plus p dz is df for this f. What is df? Do you remember this? This is called the total differential of small f, which we have learned in functions of several variables chapter. So df is, remember, it is dou f by dou x dx plus dou f by dou y dy plus dou f by dou z dz. This is what is meant by df. This we have already learned in the functions of variables chapter. That means in the first module. And you have equality of two different, this is another differential form. Look at this, something into dx plus something into dy plus something into dz. So this right side is a differential form, left side is also a differential form, and we have the equality of differential forms like equality of vectors. So this happens if and only if the first components are equal. That means m equal to dou f by dou x, n is equal to dou f by dou y, and p equal to dou f by dou z. So exact if and only if okay, we will derive that. So this is just like conservative vector fields. So what is dou m by dou y? What is dou m by dou y? Is dou by dou y of m. What is m? It is dou f by dou x equal to dou square f by dou x. And what is dou n by dou x? It is dou by dou x of n. What is n? It is dou f by dou y, right? N is dou f by dou y. And what is this? This is dou square f by dou x dou y, but the mixed partial derivatives are equal, so you will get by Euler's theorem, mixed partial derivatives theorem, you will get dou m by dou y equal to dou n by dou x, and similarly dou n by dou z equal to dou p by dou y, and dou p by dou x equal to dou m by dou z. So everything is in the previous case. So exact differential and conservative vector fields, they correspond to the same object. Just like differential forms and vector fields, they correspond to the same object. You have conservative vector fields and exact differential forms, they correspond to the same thing. So there is a one-to-one correspondence between vector fields, between conservative vector fields and exact differentials. Differential forms, sometimes we often say differential. So exact differential forms is often say exact differential. Sometimes we'll skip these forms. And this terminology, conservative vector fields, that is often used by physicists. And this is often used by mathematicians. Both are the same thing. Thank you.